The structure of vitamin B13 is shown below. How many carbon atoms and lone pairs of electrons are contained in vitamin B13? So the type of structure that we are given here is a skeletal structure. So in skeletal structures, carbon atoms and the hydrogens that are attached to carbon atoms are understood or implied. Also, lone pairs of electrons are implied. So what we need to understand is first how to find the number of carbon atoms. So the end of any bond, whether it's a single bond, a triple bond, or a double bond, is understood to be a carbon atom if it is not explicitly stated that it is something else. So the way that we say it is something else is we put the elemental symbol. For instance, the end of this line here is an oxygen, which we've indicated by putting oxygen there. So anything where we do not have that indicated is understood to be a carbon atom. So this point here is a carbon atom. Here, 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 and here are all of our carbon atoms. At the end of any of these other lines, we have indicated that it's either nitrogen or oxygen. So we can see that we have a total of 5 carbon atoms in this structure. And then the next thing we want to look at is the number of lone pairs of electrons. So our lone pairs of electrons are going to be on the nitrogen and oxygen in this molecule. And so to know this, we need to know something about the normal bonding patterns of the elements that we see. So in this structure, vitamin B13, we have carbon, hydrogen, oxygen, and nitrogen. So we want to know what a neutral atom of each of those looks like in an organic compound. So a neutral hydrogen atom tends to form just one bond to another element with no lone pairs. A neutral carbon atom will have 4 bonds. So I have drawn this with 4 single bonds. So a neutral neutral hydrogen has 1 bond. A neutral carbon has 4 bonds and no lone pairs. So I have drawn just a version with all single bonds. It could be a combination of single bonds and double or triple bonds, but the total number of covalent bonds to a neutral carbon atom is 4. A neutral nitrogen atom has 3 bonds and 1 lone pair of electrons. And finally, a neutral oxygen tends to have, or does have, 2 bonds and 2 lone pairs. And so I have, for simplicity's sake, drawn these all as single bonds. It could be also a double bond, and we see some carbon-oxygen double bonds in this structure. So a neutral oxygen tends to have 2 covalent bonds and 2 lone pairs. And so we see the same elements over and over again in organic chemistry. We see a lot of carbon, hydrogen, oxygen, nitrogen, and another common thing that we see are halogens. So I'm going to go ahead, and even though they're not included in this structure, I am going to show what a neutral halogen looks like. So your halogens are things like chlorine, bromine, and iodine, and they have 7 valence electrons, so they tend to form 1 bond and then have a full set of electrons to complete the octet. So your neutral halogens tend to form 1 bond and have 3 lone pairs. So with this information, we can go ahead and fill in the lone pairs on oxygen and nitrogen in the structure. We don't have any charges, so we know that they're neutral. So our oxygens will typically have 2 lone pairs. And so we filled all of those in, and our nitrogens will have 1 lone pair each. And so then we just need to add those up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 lone pairs. And so the correct answer here is B.